Logistic regression is a statistical technique that models the probability of an event given one or more independent variables. You'll start with input data that is of any numeric type, but the output variable will be binary. It'll be 0 or 1, indicating a false or a true value respectively. You then fit this S-shaped curve called the logistic function to this data. It can then be used to make predictions of probability whether or not an event will happen, such as, given so many hours of rain, what is the probability of a flood? Notice how that these points can project themselves onto the logistic function, and we can use maximum likelihood estimation to fit the curve, which we'll talk about shortly. Notice that there are these middle points where there is a mix of true and false cases. If these points follow a transitional trend of increasingly showing an event more likely to happen or not happen, you will see that that S-shaped curve will climb or decrease respectively. We can then leverage it to predict a probability between 0 and 1. Let's take a case where we expect 6.2 inches of rain, and this is going to result in a 0.75 or 75% probability of a flood. If we define a threshold, say 0.5, and anything greater than 0.5 will be true, anything less than 0.5 will be false, we will then predict there will be a flood. We can move this threshold based on our needs. For example, if we set it to 0.8, this would actually categorize as false and there won't be a flood. We can also reduce it to say 0.2 and set a much lower barrier to classifying a flood. This is the function that produces that S-shaped curve. E is Euler's number, which is a special constant. That beta 1x plus beta 0 is a linear function. That is actually the log odds function. That is something we will talk about in another video. What's important to know is that this function will produce that S-shaped curve we need to make predictions. We can also extend this to more input variables to create multi-dimensional logistic regressions as shown here. Let's talk briefly about maximum likelihood estimation. The way it works is that we are going to take each of these points, multiply their corresponding likelihoods together, and that is going to produce our total likelihood. We need to find the beta coefficients that will maximize the likelihood of our S-shaped curve producing all of these points. This can be done with gradient descent, Newton's method, and other optimization techniques. You might be wondering, why did I subtract the false cases from 1.0? This is because we have to treat the false cases as positive so that they are maximized as well. We will cover this on a separate video talking about maximum likelihood estimation in more depth. In a separate video, we will talk about how to handle false positives and false negatives, and we can use a confusion matrix as a tool to track prediction performance. Thank you very much for watching. I hope you enjoyed this video. If you want to support this channel, please check out my 2 books, Getting Started with SQL, as well as Essential Math for Data Science. Chapter 6 of Essential Math for Data Science actually covers logistic regression and classification algorithms in depth. Please like, subscribe, and share, and I will see you next time on 3-Minute Data Science.